Okay, so since we have only 1 hour left today, and we're going to have to run through it, but you're lucky because it's a light topic, and we're going to just introduce things that some of you have probably encountered before. I guess most of you have been writing software in some kind of level or some kind of language. Who's done it? Who's written programs?
Professionally or
no, in any way, professional or amateur or
C++ school level.
Yeah. Well, C++ is hardcore, so you're in luck. Who's been working with C#? Cool. Okay. So it'll be more interesting than I thought. So we're going to be talking about C#. Whoever doesn't know, takes its origin from a musical note. Whoever is into music will know that this is a note called C#. Yeah, sharp is the dièse that is put in front of it. It originates from a group of languages that started with actually a language called BCPL, I think, which is later changed into C, which was then enhanced to C++. And if you know the musical meaning of putting this sign, which in English is called sharp, and in other languages it's called dièse, it increments just a little bit the note. If we have in music the distances between notes, and we have this note and the next one, but halfway between this and the next we have the sharp. So a little bit like C++, when you take something and make it a little bit more like plus plus, and we'll learn the sign of plus plus when we program things. So we have also the option to increment it a little bit with this sign, and then it becomes a musical note, and it's very happy for everybody. So that will be our main topic, and that's what we're going to cover. Yeah, so we're going to be creating the first computer program in C# ever in this course today. We'll start with a few basic topics. What is computer programming? I guess most of you know it. We're going to write programs for the computer to execute and run. Computers are not very smart, and they just do what they're told. And they have, I mean, we can go into the internals of how a processor works and how a computer works and how it actually executes what you're telling them. But in the end, to make life easier for human beings, it has a structure of programming languages which are actually just like human languages, are our way to communicate with this bizarre machine. I guess most of you know, for example, if we look, for example, in our Windows directory, we'll find many computer programs, and they would usually have, let's look at something useful. For example, this genius computer software called Calc, and it's actually a calculator. I'm sure you all know it. It has an extension of exe. That means that this is already a file which is built to run on the computer, and this file has been processed from the time that it's been written by the programmer. We'll learn how to write the code, what we call the computer language, and there's a whole process that makes it into this executable file, which the operating system, our Windows, knows how to work with and how to execute and how to do actually what we told it. If we look into this file, we'll see a lot of gibberish and a lot of garbage, which is unreadable for humans, but for computers it's very optimal. So we will learn how to write the program and the tools that actually translate our program into a much more sophisticated program in the end, so that our computer can understand what the hell we want. So we're going to write our first C# program. why C#? What is C#? C# is a relatively new language in the world of languages. It's been around for a few years. Personally, I've been working with C# for like 6 years, and I've been working on it on several versions of it, starting from version 1, and today there is C# version 4 already. I mean, the whole .NET framework is always progressing and getting more sophisticated. Now, what is the .NET framework, you ask? And that's a good question, because I was about to ask that myself. The .NET framework is a set of tools. Yeah, okay, we'll just go by the slide, it will be easier. So we mentioned the computer programming language, which enables us to speak to the computer and give instructions and do what we want. Oh, wrong way. We will see the whole process of writing the programs. We'll see how we define and how we actually address a problem, and basically that's the whole idea of programming a computer. We want to solve something, we want to do something. Either we want a program that can help us edit documents, or we want to create a computer game that will waste a lot of people's time, or we want to create some financial software that will waste other people's time. So in the end, we have to define what we want to achieve, how we want to achieve it, what we want to do, and how we're going to plan what we want to write, and in the end, we will make it into code. So you will see it during the course that how actually you learn to navigate from the problem through the solution to the code, and you'll be writing a lot of code here. Okay, we'll be looking at the first C# program in a minute. But first I wanted to address the other topics in brief. The .NET Framework is also a relatively new player in the world of computer programming. It's what we call a platform. It means that it is a part that runs in the background on our Windows system, and it has parts which we can interact through our system in a more efficient way. What that means, if we want to write a computer program to display, for example, this PowerPoint presentation, we can go through a lot of hard code and hard things to create in order to, for example, to put all those icons and all the graphics and all the nice things that you can put here with the buttons that look nice when you go over them with your mouse. The .NET Framework gives you a whole set of functionality and libraries which are running in the background here, which you can also program against. Like I said, we have the computer program on one side, we have the computer on the other side, which understands things which are not so intuitive. And in the middle, we have a set of what we call libraries, which enable us to run the software in a more easier way and to write the software in an easier way. So this is a whole platform for writing programs and for running the programs. We're going to see Visual Studio as our main tool of development. I've been working with quite a few development environments, and I can say that Visual Studio is the best environment that I've worked with. As a programmer, you will see that it's great. It helps you. It helps you while you type your program. It tries to help you guess what's your next thing. Actually, you could write programs with any application. You could write programs with Notepad if you want, but a tool like Visual Studio will be very useful. Another useful tool that we'll be seeing is that I'm sure you'll be using is the MSDN library. MSDN is a short for Microsoft Developer Network, and it's a whole library of help and documentation about pretty much anything that you will need. So there is an online version of this library that you can find in msdn.microsoft.com, and you will see that pretty much everything in any topic that you will be looking for in any programming language which is supported by the Microsoft environment is here with samples with very good reference to pretty much anything. So we're going to present a simple computer program, which will be our first, and I'll demonstrate exactly how we write it and how we run it with Visual Studio. One thing about this specific program, you can see, you will see that what it does is print these words, hello C#. And every first program ever written in any book, in any programming book, and in any programming course is usually hello something. And it comes from the original program, which was printing hello world. It's a very known concept. Just to pay a little tribute to a person who is very much the father of all this, who passed away last month. And I'm not talking about this guy. I'm talking about this guy. This guy is Dennis Ritchie, and he is the author of this book, which was my first university programming book. It's one of the most fundamental books in the world of programming, and it's one of the most famous. It was written by these two guys, Kernighan and Ritchie, and Dennis Ritchie passed away last month, and he is one of the fathers of the C programming language, which all the newer languages come from. And this is the first book where the program which prints out hello world was presented, and this is the fundamental father of all programs. So we'll see the structure of this program as we go along. Okay, we're going to have to analyze what's going on here. We'll start with the interior. With C# you can write programs which run on various technologies in various ways. For example, you can write Windows applications that will open Windows and pop-up messages and what we call dialog boxes. You can write applications for Internet users and Internet Explorer, and you can write Internet applications of all kinds at all levels. You can write database applications. We're going to start with applications that write, that interact with the user and write text out on a console window, which is like the old versions of MS-DOS, pretty much like this one. Yeah, this is also a computer program. It's also running inside Windows, and we can also interact with it and write things in it, and it will give us an output. And we'll be writing inside our first program inside this one, and in the programming world this would be called a console. So nope. So the first part that is worth noticing here is that we have an address of the console. The second part, which is easy to read and understand, is the fact that we are trying to write something into the console. We're trying to write text into a line, and this would be a Writeline command that will be understanding more the interior of the structure of this writing as we go further. Here we have the text that we're trying to write out. One more thing to notice is that this thing is wrapped inside a block which consists of these two brackets, which you're going to see a lot of. Once we have a block which starts and ends like this, we have one unit of code, of program, which is running in itself. So we'll see more about this later, but you can see that we have here already two levels of such brackets. And you can see that on top of each one of them, we are defining what this thing refers to. So we'll see more about the structure as we go, but let's just assume now that this is a first part of our program, and we call it main. this is something that we have to name it like that. We also have the name of our wrapping thing, which is above this main, which we'll see. We'll learn more about the structure as we go. I think that this will be better understood as we go further. So here you can see again the structure of those brackets, as we have our main block and wrapped with it our what we call a class. We'll learn more about classes further. And we have the using statement, which we'll also address. Again, I'll cover all of these things when we see this actually working. One thing to notice when you write computer programs is that you have to keep them well structured. You can write code like this. The programming environment doesn't care about what we call white spaces. It could be with empty lines, it could be with spaces, it could be with tabs. The computer doesn't care about how your program is structured, but other programmers do care about this. And when you write a computer program, you might want to try to keep it well structured like this, where you can see exactly where everything starts and ends, and which parts are nested within each part, rather than writing something like that. That's very difficult to read, and personally, I wouldn't recommend anybody to write anything like this. So, we'll see more about the structure, and we're going to demonstrate the first program in the live demo, and that will be, I guess, more clear to you. So once again, covering what is a computer language, I think we've already talked. By the way, if anything is not completely clear, I mean, I know that you're all engineers at one level or another, but if anything which I'm explaining is not completely clear, feel free to ask me at any time, because it's important to have as much as possible clear here. So a little bit about the C# language. As we said, it's quite new. It's been around for a few years, and it's always renewing itself. It has new technologies. It supports new libraries, and today it's a very powerful language which can be used for many applications, for many types of applications. And personally, I like using it. It's, like I said, it's powerful. It has a lot of features. It's relatively easy to learn. It's not as difficult as C++. C++ is much more low-level program, and let's say that as a programmer who works with C#, you'll have to struggle less with your program. Some of the things are done for you behind the scenes that you don't have to work so hard for. It's easy to read. It's easy to understand. It's easy to write, and the fact that this bullet about object-oriented will be more clear as we learn the language. Let's just say that object-oriented languages copy models from real life into the computer, which makes it easier for the programmer to construct the solutions. For example, if I'm constructing my program which will manage a group of students, for example, and I want to keep track of the students' name and age and their scores and their hobbies and which courses are they taking, I can start by constructing into my program a structure that will represent the whole student. For example, the student's name and age and all the other fields that we were talking about. And this can be built quite naturally into the program. So this methodology is called object-oriented. It's supported by most of the let's say, leading programming languages in the world, including C#, including Java, including C++, including JavaScript. And this is an important concept to notice. We will see, again, the whole route of how we solve problems and how we build our program from start to finish and how we address a problem. We will see the different libraries of C++. We'll get to know the framework. We'll get to know the documentation and the MSDN library, which I think I also have it installed here offline so we can see it in a little more details. Any questions so far? All right. I'm sorry, I know that this is a late start, and after talking for 2 hours about Telerik and the course, and people here are after a working day, including myself, and starting from 9 to 10. And I hope that next time we'll be more fresh. We'll start around 6 o'clock, and we'll jump into more live demos so you can see and participate, and you'll have time for exercises and questions and answers. So let's start by kicking off our tool. I'm using Visual Studio 2010. As I said, according to me, the best programming tool, one of the best, if not the very best. Very useful. It's used here in Telerik, and there is already a version of 2012 which is not completely finished, but it is already usable. So this is our interface. This is what happens when you open it, and there are all kinds of windows from all sides that are popping up, and they are very useful for us. We'll see them again as we go along. Usually when we come to solve our problem and we already have an idea what we're going to do and how we're going to do it, we're going to have to create a project. A project contains our program, contains our program files, our code, contains external files that we could be using, for example, images if you want to use in your application, all kinds of external text files. So we're going to start by creating a project, and I'm going to start it here. From the file menu, there's a new option, and there's an option to create a project. When I do that, you can see that there are many types of projects that can be created, and there are many types of solutions that this environment can give us in all kinds of languages, by the way. Right now, the primary language that I'm addressing is C#, but there are other languages. Can you see, by the way? Can you see the board? If I want to write my solution with C++, it also gives me the help. And if you look at the options for Visual C++, you'll see that there are many types of solutions and types of projects that I can create for C++ as well, and other languages. So we're going to start with the C#, and naturally the easiest way to start focusing on the language itself, not only on external aspects of it, we're going to start, as I said, with a console application, which is quite simple. It doesn't have any fancy user interface, but it is useful just to focus on what we're doing. One thing that we are requested to do is to choose where we're going to put our project. So I'm going to choose just a folder, local folder on my computer. The next part is to give a name to our project, which is, as Svetlin mentioned, important. One thing I can say about writing code and writing it properly, like we saw on the PowerPoint, you can write it in a very messed up way, and you can have your lines cut in all kinds of directions, which will be completely unreadable. Another aspect of writing good code, which you'll be expected, is to write it, to name your program, to name your variables, to name your functions, all in a readable, understandable way. In the older versions of Visual Studio, don't remember which one, when you open Visual Studio every time, there used to be a tip of the day window, which was popping up and giving you all kinds of tips. One of them is don't run with scissors and all kinds of such tips. And one of them, actually there was an email which was running around. This was in the pre-Facebook time. There was an email running around with a screenshot of this opening window with the tip of the day, and it says, because it's Visual Studio, it said, write your code as if the person who's going to check your code is a mass murderer who knows where you live. So this is also my recommendation for you. You don't know who is a serial killer and who is not, so don't risk it. And always write your code in a nice, neat way. Don't make anybody angry. Give it nice names so they can understand what you're doing. And that's just a tip for you not to aggravate serial killers. So we're going to call this something like our first program. We can see that there are all kinds of settings here, but basically this is going to be our application. And so once I click OK, things start happening. And I think they're still happening. And now they're not happening anymore. Okay, so let me close this and this and open something more standard. Okay, as you can see now, my window is split into two. And on the right side, we have what we call the Solution Explorer. When we write our programs, like we said, we're always planning to solve something. We are starting from a problem. And our program, since we are the good guys, comes to solve the problem. That's why Microsoft chose to wrap your programs and your projects in a bigger wrapping, which they call a solution. So actually, when you write your software, and in many cases when you get to write professional software, when you get to work in bigger projects, you will have not just one project running around, you'll have many projects. And they will usually be wrapped and encapsulated in what's called a solution. So, so right now, we have here our solution, which is called our first program, as we named it. Inside it, we can see that there is, inside it we can see that there is one project, which is a C# project, which is also called, surprisingly, our first program. And inside this project, we have our project files, and one of them is called program.cs, because that's the default name that console applications get. So we have our console application that will become an executable that will run under Windows and will open this black window that we saw. It currently has one file inside it, which holds all the code, and we have a wrapping solution that we can add further projects if we want. And in further levels of this course, I guess you'll be using more than one project at a time. It's always good to cut your solution into projects that make sense. This is also a part of making sense. Always write when things are making sense. Always write clear as much as possible. If you have a very complicated solution and you need to hold the students on one side and you need to hold the database connection on the other, just cut them into projects and work with them separately, and then wrap them in a nice solution, and everybody will be happy. So our solution contains one file. Our project contains one file, and this is it. All these lines at the top right now are not very necessary, and they don't mean much, but they are parts of the system, parts of the .NET Framework, and they are telling our program which parts are being used right now. Since the .NET Framework is very big and it has many complex parts, some of them are for graphics, some of them are for databases, some of them are for language and localizations, some of them are for console applications, and some of them are Windows fonts, some of them for internet applications. It cannot be that you're building a program that uses all of them and can include all the robust technologies of .NET. Once you write a file that uses certain code, then you will probably need certain aspects of the .NET libraries. Or you can use other parts of your own libraries or other projects or other solutions included in your project. So at the top of the file, we have all the using statements, which actually tell our program, our environment, what parts of the system we are using. One part which is almost always used is the system. The system is the root, is the top level of pretty much most computer programs written in .NET. It holds all the most basic parts of this platform. So in most cases, you'll be using the system part of it. And if you need specific parts, for example, if you need to query some data, then you'll be needing to use the link query part of it, which we are not going to cover, obviously, today. So these are just some sample lines which are inserted by default, because they are the most useful ones. It is most common to use link queries or text or some kind of collections if you want to organize your data. So this is why these are the ones which are given by default. Then we have our namespace. Namespace is an important aspect of any C# language, of any part of your solution, of any part of your project. And as its name applies, it has to do with the naming, which is also, as I mentioned, an important part of your writing good code. Namespaces just divide your programs into logical parts. That means that if we have a part which handles the students, then we would probably use the namespace which is called students. This is just a logical separation of your of your program parts. So we'll be seeing more about namespaces later. But for now, we are getting a default namespace, which is named just like our project and not like our solution. Because if anybody else wants to use the code that we write here, or if any other project in our solution will use this code, they will have to address it, first of all, by the namespace. So they will know that they are actually referring to the part which is called our first program. Does this make sense? Okay. Next we have, sorry? Question? No question.
I was thinking, if you so you don't refer to a class directly, but first to the namespace, then to the
Yes,
class?
usually you refer to the namespace. I can demonstrate it. Although, if you include the namespaces in the using statements here, then you can address directly the class. But this is just a form of making it shorter.
Okay.
Sorry?
So we don't have libraries here, and they are replaced by namespaces.
We have, if we look again in our Solution Explorer, we'll see the structure of everything our project contains, and we will see that it contains a few references. That means that this program, as small as it is, already takes parts of the .NET library and puts them here. Referencing means that we are taking pre-built parts, pre-built programs, pre-built DLL files, other projects, and just want to use their functionality in our program. So by default, since we didn't do anything yet, we just created the solution, the .NET Framework and the Visual Studio added into our solution a list of references which are most common. For example, you will have to use the system, again, as we said, which is the very basic hard core of the .NET Framework execution area. So these are references which are added already into our project, and we can use them. For example, if I want to address some of the classes which are in the Microsoft C# library, I will be able probably to use them here. Yeah, as I write along, this shouldn't make much sense, I guess, to many of you, but you can see, and you'll see it a lot more, that as I write my code, this Visual Studio environment it helps me, and it shows me what are my options at every point in time, which is very cool. So we can address, but by the way, when I'm writing Microsoft.C#, I'm addressing the namespace and then the class. So there's a whole hierarchy of namespaces and classes that we'll see furthermore what exactly they are and how they work. But as you can see at first look, this program, as we saw, contains a hierarchical structure. We have those curly braces here, and whenever we open a curly brace, we have to close it, and if you don't, you will have problems. So as you can see, we are enclosing parts of the program within those curly braces, and we have our namespace, and inside it we have our first class. As we mentioned, C# is question?
Yeah, I had a question.
Oh, sorry.
Thank you, by the way. I didn't want to interrupt you, but
Oh,
the question was if I wanted to, down the road, let's say based on the specifics of the software program that you're doing, and we want to insert additional libraries like the colleague said, additional functionality, do we insert it on that right-hand side which you just showed?
Mm-hmm.
So we go on the MSDN library,
Yeah.
we choose, we read through, we define our functionality we're looking for, and we drag and drop into
Yeah, drag and drop. Basically, we'll see more of that, but if you can see what I'm doing, if I go to this part which is called Solution Explorer, everything in Microsoft is called something with Explorer, so especially if it gives it in such a nice hierarchical view, then if we go to our references and we right-click, we can add more references to our project. And here we have a few options. We can insert other projects which are in our solution. They can refer to each other, or we can just go to the .NET Framework and we'll see a big list of assemblies and big list of predefined libraries that we can use.
How do I know how each single one, what each single one does?
Because you are smart. And you are going to read a lot of references, and you'll be even smarter. And you'll go to the MSDN library, and if you are building a database application, you'll read a lot of referencing about ADO.NET and which libraries it uses, and then you will know exactly what you're going to add here.
Why not just be sure and add them all?
Good question. Why not just be sure and add them all?
Well, it will solve
What will happen if you add them all?
That was a joke.
Ah. Okay. Which is good.
Now, what?
No, you have to structure your...
That's a good question. What happens if you add them all? I mean, does it take up computing space to do the program when it starts, tries to reference more switching, or is it
Yeah. Okay. If we add more references, our program will know that it's referencing more data, and it will try to address those references when it starts running. It will make it much more bloated with unnecessary information, with unnecessary... First of all, if we are not using something, And if it's a reference which is included in some kind of DLL file, which in the .NET world we'll call mostly assembly, then if it's unnecessary, it could be left out, for example, when you ship your solution, when you ship your product. And all the unnecessary referencing is not efficient. It takes of your program runtime attention. It gets your program, first of all, it will probably not run if you are missing references. And once you have problems with references which are, let's say, unnecessary, you'll just make you'll have to include them with your program, and they'll be just put in the folder and making it big, and your program will run slower. And you have to be efficient, and usually you have to pick which parts you're going to use according to your needs, and it's important. Any more? Okay, so far we're clear, right, on what's happening here, I hope, not just for the people who say yes. So our most basic building block when we are building a C# application is the class. We will see a lot more of that. But one thing to know about the class is that it's used to wrap things, like I mentioned, in a more intuitive way. Usually things which are related to each other will be in one class. If you are managing, for example, again, a student, an entity in the world of your running application, which is called a student, then we would usually wrap it in a class, and we will have all the properties and all the values and all the functionality that a student can have. This is an important concept that you'll have to put in you. I'm sure that everybody who's been writing a computer program or two in the recent years, and since I think most of you are younger than me, you have been doing it in the recent years, you must have seen structures of programs which are consisting of classes. So a class is an important building block which is in C# has to be used. There are other languages where you don't really need to build your own classes. They are optional. But C# requires you to always wrap your data in classes. It needs to. So since we have our first program, we are given as a gift a new class here, which is called program, which is the default class name that we have for all applications which we create like this, which are console applications. And inside this class, we have absolutely nothing except another block which is wrapped with those curly braces. And this is our first functional piece of program. We will see more about functional pieces of program, which are naturally called functions, a lot later. But you can understand that everything that I will write here will be, in the end, executed by the Windows. This is where I start to give instructions. So the first and only instruction that we're going to give here is going to be this. Okay, what do we have here? Like we said, everything is wrapped in classes, and inside those classes we have our functionalities. And as we could see here, most of the classes are wrapped in namespaces that help us also find out and know where they belong to in the hierarchy of the whole huge amount of data that is called the .NET Framework. So you can see that the first line is now not so grayed out, and it's maybe useful. We are using in this program the namespace, the first and most basic namespace, which is called system. If we didn't use it, and I would delete this line, we would see that I already have a problem here. So if I want to write this properly, this means that we are using, first of all, the most basic namespace of the .NET, which is called system. Inside it, there is a class, just like this structure that we have here, which is called console. Inside this class, there is a functional code block, which is called Writeline. And this is how I make this code of block run. You will see a lot of this. You'll have to investigate in your book, and you'll have to write such programs starting from this lesson's exercises. Once I want to address this code of block, this other functional code, and run it, I'll have to open my brackets, close them, of course, because we have to close everything. And inside it, I'm writing the text that I want to display. Text is wrapped with double quotes. This is how C# knows that you're handling text. This is similar to other languages, like that. And one important thing to note here is that every execution part of the program, every line, must be ending with a semicolon. So, if I don't want to use, by the way, the namespace right in my code, I can make it shorter, and I will return the system namespace into the using statements here. So that means I don't have to write every time system dot something. I can address all the system components directly by their class names, and because I'm using here the system, it will by default know that I can address all the system classes. All the rest of these lines are not necessary. The next thing to do is to build our solution. We have this option in the main menu. And what happens now is if we go into our folder, we will see that we have a binary folder which is called bin. Inside it we have another folder called debug, because this is the configuration that we are building right now. We can build our program as a debug program or as a release program, and we'll see more of that. And inside it there is an executable file which is called our first program.exe, and that's already a program that knows how to run in Windows and execute what you tell it. So Visual Studio took this and made it into this. When we run it, I guess it'll be fast. Yeah. You saw that it opened a window and closed it. That's because it opened the window, did what we asked it, finished, and exited. So one way to run our program is directly from a command window. So we could open a command window like this. We could navigate to our folder, and we could just run it from here by typing the name of our executable. And when we hit enter, it will run it, and we can see the text that we wrote above. We can, and you will.
Question. On my end here, it just says our first program .vs host .exe.
Yeah. Okay. except our executable, there are all kinds of other files here which are generated by Visual Studio. These files with the VS host, VS stands for Visual Studio, and these are files which are usually placed here when we are building a debug program, and these are helpers that help us run our program within Visual Studio and debug it. We'll see a lot more about debugging as we go. So all the others are generated for us on when we build a solution, but the important file is our executable. Yeah. So let's go on with a few concepts here. We spoke about the .NET Framework and about the fact that it's a whole platform for running and building and executing our programs under Windows. It is not an integral part of all Windows, and the .NET Framework always evolves. It always gets new versions and new libraries and new abilities and new functionalities. And the .NET Framework version 4, you cannot compare it to the .NET Framework version 1. It has a vast number of applications that you can make that you couldn't make before. So this is a big part made of many parts that need to be installed on your Windows in order to run the application. Even though it looks like an exe program, it's not like the calc application which we ran from the Windows. When we run our application that we built here, since we built it with the .NET platform and we built it with the .NET Framework, if you want to run it, you will need on the Windows to have your .NET Framework installed. On the newer versions of Windows, this comes built in, but if you need, for example, .NET Framework version 4 or 5 when it comes out, you will have to install it afterwards yourself. So it's a whole runtime environment, and it's a construction environment for us as programmers to build our software, and Visual Studio will make it easy for us. One thing to know about the .NET Framework, by the way, it's very much closely connected with C#. C# is a language that was introduced with the .NET Framework, and as we mentioned, it has a lot of characteristics from other languages like C++ and Java and JavaScript, especially in the structural side of it and in the fact that we're building classes, which is a common thing. But basically, you can build applications on the .NET Framework, and they will run just as well with a very big number of languages. There is an option to build it with Visual Basic, which personally I don't like so much. But some people say it's easier to build with it. There is a version of C++ which is built onto this framework. There are versions of Python, and there are versions of JavaScript, and there are versions of a vast number of languages that you can use. And in the end, once you build your solution just like we did, they will become executables just the same way. This framework, what it does, takes you the code that you've been writing and transfers it into the code that can run on the framework, and it's always generating the same code in the end. So you can actually write it in a variety of languages. The framework and the development environment will always transform it into something uniform. So this is displaying the layers of this framework a little bit. At the bottom, we have our operating system. That's our Windows. That's the real hardcore where the things happen. This controls memory. This controls your screen. This controls your mouse. This controls your files. But since it's not very comfortable to work at this low level and working on every bit and pieces, there are a few layers built on top of it. The most basic one is called CLR, Common Runtime Language. This is the part that you have to have installed on your Windows in order to run .NET applications. This part executes your build executables, and it is important. Yeah? Good question. Yes and no. it is the basic idea of the virtual machine, which, let's say, should give it platform independence. But the way that the program is compiled in the end and executed is somewhat different than it is. But let's say, okay, the idea is quite similar, that you can have it installed. You have some kind of runtime platform installed on your computer, and you can build your solution into something that knows how to run on it, and it can run. There is even a .NET porting into Linux that is called Mono, that you can run your applications there. So it is pretty much, let's say, similar, but it has the differences from the Java virtual machine. On top of that, we have, as we go higher, we have our class libraries, like system that we just used, or all the other libraries that give us access to everything down here. And as we go up and up, we are getting more and more into humanly read components, which are building it into different pieces of the software. Actually, .NET Framework can run on your web server, so you can build web applications. It can run on your Windows machine, so you can build Windows application. It can run as these technologies, WPF and Silverlight, which allow you to build complex user interfaces regardless of where they are running. It could be on the web, it could be on Windows. And on top of all that, we have our programming languages, and that's where we come in. And basically, in more detail, here is where we come in on the C#. So we're building our applications here, and we can use all these libraries here. And in the end, we'll get an executable that will execute against this part and will speak for us with the operating system. So this is the whole level of layering and how it is constructed. And of course, you have to know all this for your exam. As we mentioned, we have the common runtime environment. It executes our programs. In the end, we have our compiled code, our code that is generated for us, which can be run against it. And this is the part which is important to have installed and to be running on your machine. We'll just go over those layers very quickly, because I think you will not need to know every part of that. But as we mentioned, we have our class libraries, our basic libraries, which contain all kinds of components which you can use in your applications, and you will use them on further projects. We've seen Visual Studio. I warmly recommend to work with it. Get somehow a license for Visual Studio 2010. Since we've seen already in the live demo, we can write our code there, we can manage our references, we can manage multiple projects, and we can wrap them in solutions. One more part of Visual Studio is the help, which if we open it, I think I have okay. I think I have an offline version of MSDN Library here. So this is part of the Visual Studio help. It contains everything that you can imagine, which is related to any technology supported by Microsoft. For example, if I look here for the console, we should be getting quite a lot of information. But I'll just open, for example, a page, and we can see here a full reference of everything you need to know about the console, how it works, what it supports. You have a whole list of features here. And for example, if we go to the members, we can see all the properties and all the functions and what they do. And if you want to know how to use Writeline like we did, we can see that there are all kinds of versions of Writeline. we were using specifically this one with a string, not this one with a string, and you can see exactly how it's constructed. There are even code samples here. In all kinds of languages, you can get a code sample written in C# or in VB or in C++. You'll see how it's constructed. You'll get everything. And it's been said that getting Microsoft help is like somebody who wants a glass of water and he's being run over with a fire hose. So there's a lot of help. There is an online version of MSDN Library. You don't need to download it. You just go to msdn.microsoft.com, and everything is here online, the same search and the same results and the same data. So that's a very useful tool. It is built in Visual Studio. So once you're looking for anything, once you need any help from this environment, it will throw you into the MSDN library, either the online or the offline, depends what you have. Yeah, we've seen all this about Visual Studio, if you have questions about it. This is the environment as we could see it in the live demo. We have our Solution Explorer, this part, and as we can see in this screenshot, we have a solution hub here, which is called Demos, and inside it, there are a number of projects, and each one of them with a number of files and references. We can see here the code as it's written. One thing that you can notice is that the code is colored in different colors. That makes programmers' lives easier, so they can know what they see. It's easier to spot whether this is a string, or this is a class, or this is a namespace, or this is a word which is used by the framework in any other way. Question? Exam? Result. Mm-hmm. The result.
She's trying to ask the program that we made for Telerik, C# after it executes,
yes.
Go, but it just appears for a second.
Yeah, a program, normally a computer program runs. Once it finishes what you asked it to do, it stops running and it closes. So that's the normal cycle of a program. Yeah.
Does it have something like the system pause command?
There are, yeah, of course. There are many ways to pause it. An easy way is to just ask the user for a key click, and you can implement that. We will. And another thing that we see here is process of debugging, which we will do quite a lot of. We can see our code during its running. We can see what's happening. We can stop at a specific line and we can see what's going on. We can see the values of everything. We can inspect our variables, which we'll do quite a lot on the next lesson. So this follows the demo that we've seen. You can download this PowerPoint, and it has all the steps that we've seen. How to create a project, how to create your first program, what parts that we've seen, for example, the namespace, the class, the using statements, which means what we include in our program.
Quick question, how do you set the program to see the variables and stuff? Interface question in the Visual Studio interface.
You mean when you are debugging?
Yes, these debug windows, if you don't have them...
You can address all the debug windows through the menu called Debug and Windows. And here, not all of them actually. You will see that you'll see it in debug mode while you are in debugging. But there are all kinds of output, and there is the watch window. But we can see it if I'll enter a debug mode for 1 second. So we have the watch window, and if you don't see it, you should be able to add it through. Yeah, now in the debug windows we have all the options. We'll see more about debugging on the next. We've seen how we build the solution. We'll see how we can debug our programs. That means that we can inspect during. We saw that when we run the program, it runs very fast, it does what it does, and it finishes and it closes, and we'll see how we can stop it and look into it while it's running. This is a basic operation that every one of you will have to do in order to find mistakes in your programs. This environment, of course, will not let you build a program which has mistakes. For example, if I leave out the semicolon that I have to put at the end of the line, and then I try to build my solution again, we'll see that I have now an error that tells me that the semicolon is expected. And if I double-click here, it will send me to the source of the problem.
It sends you not just to the line with the error, but exactly the place
Yes.
where the semicolon is at.
Yes, but let me try one more thing. Let's suppose that I add another line here that's writing the console Writeline, and this line is fine. Yeah, it's smart enough to send you there, because in previous versions of work environments that I've worked with, usually it would say that the problem is in the second line, because the second line is just there, but it was expecting a semicolon before it started. But Visual Studio is smart enough to send you exactly to the point where you need to fix. Yeah, as I mentioned, it has the built-in debugger. We'll be putting a lot of breakpoints, and we'll be inspecting the programs as they run. The next lesson, we're going to talk a lot about variables, and these are actually the storage pieces of information for our programs, and we'll be using a lot of them. And I guess we'll be seeing a lot of debugging in the next lesson. We've seen the MSDN library. Yeah. We're pretty much close to a finishing line, so if anything of the things that are now being recapped here is not clear, feel free to ask me. So the MSDN library, as I mentioned, is a huge library. It contains a lot of information about pretty much any topic which is covered by Microsoft technologies that you can imagine. Just go to msdn.microsoft.com and you'll be happy. That's the website. There's an offline version that can be downloaded. It's quite big, but I've installed it here. It's very useful if you're working and you need a lot of help referencing. Yeah. Any questions? Yeah.
Are all the questions at the end of each chapter going to be writing them all in Visual Studio, or is there going to be any pseudocode written on paper? What's the situation?
Excellent question. Actually, one of the best questions I've heard.
Thank you.
Yes.
I appreciate it.
Okay. The question is, these exercises come to help you learn. I mean, for example, here we have an exercise for writing an application just like we did right now. In many cases, when you're writing a more complex application, when you have to plan what you're writing, and since you're going to go into algorithms and into more complex programming methodologies, it is sometimes better, if you are really writing something complex, it's sometimes better to write pseudocode and to first formulate your thought about how the solution is structured. It's not necessary, I think. Once you have a task of an exercise, the the task is to provide the code that you are requested, unless you are specifically asked to provide pseudocode with your code. It's a good practice sometimes, especially when you're dealing with algorithms and data structures, to first structure your thought without actually writing it into code. Once you have the fake code at one side, it's easy to take this and transform it into real code. It's good practice at some point, but I don't think it's necessary unless it's specifically requested. Anything else?
Are these all the tasks for this exercise?
No, these are just the first 3.
How many?
12. Since we started late this time, we don't have much time and we're pretty much rushing in, and I'm trying to make things as clear as possible, even though it's hard to get into every bit and piece. I hope that things were clear here. On the next time, we're going to start, as I said earlier, and that means we're going to have, I hope, time for you to start working on these exercises here, and I'll be here to help you if you have any questions about them. So that will make it easier.
This one for homework now?
Yes, these are the ones.
Deadline? 2 weeks?
I think it's 1 week from today. Yeah, from
Next time.
yeah, from now.
Do we, can we submit them all in one project, or do they have to be separate files?
I recommend you to separate your tasks into separate projects.
Separate project, but in one solution.
That's up to you. Since they are not related to each other, you can just create a solution, yeah, for each one. You can put them all in one solution if you want. I think since they are not related, just put them in separate folders, separate solutions, separate projects. Yes, sir.
My question is, what if we want to, instead of for each single one, do a program, can we just copy and paste the code and put it in a Word document, and then forward that off, or do we have to make binary executable files for each single problem? What?
You don't need the result executable file because this is generated. This is generated for you. This is not your work, but the code and building it into a solution in a project is your task. So what you'll have to provide is a zip archive of a folder which contains the files that you've been working on, a solution, a project. You can put them in a Word document, but that's not going to be sufficient as a computer program unless you're writing Word, and we're not there yet. Anything else? Yeah.
What about the task with stuff? For example, debug task sounds so complicated. I'm not sure if I
I think the star is explained down here. You're going to have to research. Yeah.
Age from the console and click code.
You're going to have to research. You're going to have to put yourself in a mindset of finding your ways. And from my experience, I can tell you this happens all the time. Nobody knows the .NET Framework fully. I work in the Sitefinity team. I'm a senior developer there for more than 2 years. Like Svetlin said, there are like a few million lines of code there. I haven't seen them all. I don't know all of them. I don't know all the parts. But this is what happens when you work on such a huge project. And it always takes research. We have now, for example, a new task that we have to address, which we haven't worked on before, and we'll have to research on how to do it. This is something which is a part of the programmer's life all the time. You'll have to always learn and teach yourself and find your solutions and copy paste.
I assume it's an educated guess to say that the syntax in C++ and C# are similar.
That's an educated guess, but it's wrong. it's not fully similar. There are similarities between C++ and C#, but they are not the same syntax. They have similarities, for example, the word class and the way that classes are structured with curly braces. C++, for example, natively doesn't use namespaces like that. Or there are many keywords in C# which are not used in C++ and the other way.
MS have brackets and after the type of the variable in C# and in C++ it was after the name of the variable.
Yeah, and all the biggest part of C++ is the parts with pointers and memory allocations, and these things are usually not used like that in C# at all. It can be, but it's quite advanced.
They're used behind the scenes, right?
Yes, we'll see a lot about that. That's it. I'll leave you with a logical joke because you are now more into computers and logics. If you can understand this joke, you are in a good condition.
I don't know. Yes.
Does everyone want beer? So, by the way, these are three logical experts in the bar. So
if you don't know and one says yes, so that everyone wants to.
yeah, the first one wants a beer, but it doesn't know if everyone wants a beer. So it only knows for itself. So it cannot answer the question for everyone. So he says, I don't know. If he said no, then it's of course, then it's not everyone wants. Then he would know for certain to say no. The second one still doesn't know because he wants a beer, but he doesn't know if the third guy wants a beer. And the third guy wants a beer, and he knows now that everybody wants a beer. You'll have to get yourself into logic, into a way of thinking. I've been teaching programming courses since 2001, and it's a different mindset that you'll have to get used to. Of course, all of you are bright engineers, so that won't be a problem, but it's a different way of thinking, that logical way of thinking that you'll have to accept and to get used to. So there'll be a lot of logical and geeky jokes going around to get you into the mood. Yeah, it's a good one.
Yeah.
Any more questions? Yeah.
We need to write our homework, so because I was questioning describe the
I guess it could be okay if you write them in Bulgarian too. But okay, the programs will have to be in C#. Yeah.
Excuse me, about homeworks. Do we need to upload only the CS file or from the homework?
No, you'll have to upload the whole solution with all its files. Just when you create the solution like I did here, it will be created in a folder. So inside this folder you'll have the SLN file, that's the solution file, and all the other files created around it, the project file, the CS file. All you have to do is take all this, add it into some archive, and you're good to go. Either zip, rar, and at the top of all that, you better put them all into separate folders because we have different questions and different tasks. Put them all in separation, then wrap it all and send it. And that's it.
Send all of them to separate folders and make them into another archive?
No, I think you can make all of them into one archive. Or
I think the form only accepted archives solution. We must limit each task separately.
I'm not sure about that, but check it. I'm not sure about the form and the task.
accepted, I think, on RAR on top.
Okay, guys. Thank you.